Alright, welcome back again to another day, Wednesday, the what? 7th of October. And today we're going to continue our series of geometry in everything mathematics. I honestly thought today it would have been a content video, but unfortunately, again, not unfortunately, because again, it's important to understand the content. But yes, in this video, we'll be looking at another content area, another laying down of the concept of triangles. So what are we going to do today, Red? So firstly, we're going to look at the definition of a triangle. So we understand what is a triangle. We're going to look at the sum of interior angles in a triangle, or at least clear that or lay that foundation in case we don't know. And then we're going to look at the main types of triangle. And as a bonus, of course, I will show you the other types of triangle, but I'll just address the main ones. The bonus ones are very easy to identify and associate with. So, what is a triangle? Here I have two different definitions for them. So a triangle is basically a polygon with three sides and three angles. That does it. That does it. Or a triangle is a two-dimensional shape with three sides and three angles. Notice in both of them, just two different ways of saying the same thing, but in essence, and I think we all know what a triangle looks like. So for a triangle to be a triangle, it must have three sides and it must have three angles. That is a triangle. So any day, any way you see that, you know that you have a triangle. Simply put, no arguments there. Let's look at the sum of interior angles. And by the sum of the interior angles, I mean, remember we just established, a triangle will always have three angles. How much will these angles add up to? Good. I mean, if you was in a practical class, of course, I would gladly experiment. There are two experiments that I know that you could figure this out on your own. But we're on YouTube, so I'll just tell you. All the angles in a triangle add up to 180 degrees. Always, always, always. You cannot get more, you cannot get less. When you add all three angles, each and every angle, you will always get 180 degrees. And understanding that concept is key because with that concept, of course, we could apply some algebra. I could give you two and make you find the third. I could give you one and make you find the missing two. And yes, all these things are possible when we understand some properties and qualities of a triangle. As I told you way back when we did algebra, maybe I will tag that video to this. But whenever you are asked to find an unknown, you will always be presented with what is needed. And we're going to play with that thought later, but definitely not in this video. So just for perspective, so imagine if this angle was 60 degrees and this angle was 60 degrees, then I could ask you, what is x? That is one way to look at it. And again, remember, we know, okay, all these angles supposed to add up to 180. So, of course, you could do your algebra, but I ain't going there today, and work out what is x. Because you know that 60 plus x will be equal to 180. But I ain't solving it for you today, since that is not my focus. But we know when we work it out, we're supposed to get 60 degrees here. Likewise over here. And this is again understanding terminology. This one by default is 90 degrees. Well, not by default. We know this is a 90 degrees angle. So let us say, if I told you that this side is 60 degrees, let's just imagine. If I told you that that side is 60 degrees, then you have to be able to work out that this side over here will be 30 degrees. And I would leave you with that thought. I wouldn't work it out. That's not my aim today. So let's move on. Let's look at the main types of triangle. And I call them main because every other type stems to this. And in fact, to be honest with you, the other types can also be found in the main types. And you will see why I'm saying that later on the line. So for example, let's go. So we have an isosceles triangle. That's one of the main types. Then we have what we call an equilateral triangle or equilateral triangle. I don't know what you call it. English is not my mother tongue. And then we have the scalene triangle. I consider these three as the main types. And this is me saying, like me, Yaga decide. I'm not saying that is what it is. I'm not saying that is how it is. But that is how I personally see it. And I see the others as just byproduct. Good? So let's deep into these three types of triangle. One thing I should make clear, let me just get that out of the way. There are two things that really and truly classifies a triangle. That is the number of sides and the angles. And those two things also qualifies the type of triangle. So for we to know why an isosceles is an isosceles, then again we have to look at the sides and the angles. What makes an isosceles triangle an isosceles triangle? Here we go. An isosceles triangle has two equal sides and two equal angles. And that is what makes an isosceles triangle. So if you have an isosceles triangle and you know that, or you could tell that two sides are equal by default, we know that is an isosceles. And I will just show you two ways in which you could identify it, one more obvious than the other. So obviously, for example, if I say this side is 8 centimeters, and I also told you that this side over here is 8 centimeters. So without thinking twice, oh well no, let me be more clear, because then you might think here is 8 too. Let me say here is 10, because here kind of does look long. So this is the first scenario. Okay, there you see it already. Two sides are equal, and by definition, once two sides are equal, guess what? It's not no if but main. By default, that is what we go work on. And I proved that myself. To be honest, when I did this in school, I literally go and draw random wild and random triangles, and I make sure that two sides equal. And I just make the third side meet. And always, in my discovery, always, if this angle here measures x degree, guess what? Here will also measure x degree. And that's one of the beauties I always like about maths. I used to always go and prove things and see if it's true. Yeah, literally, like literally. What could be proven literally? Yes, I would go literally and prove it. So for example, I remember when I was doing conversion some time ago, and the teacher tell me what? If you convert, well, I mean, I understand better now, but back then I was kind of stupid. So if you convert 3 centimeters, you will end up getting 30 millimeters. But I didn't leave that day. I literally went and drew it with a ruler, and I measure it in centimeter and I measure it in millimeter. And indeed, when I measure 3 centimeter with the length of a line, and then I use a millimeter ruler and I measure 30 millimeter, the length was the same. Oh yes, believe it. Those are things that I went as far as doing just to make sure that, yeah, certain things were copacetic. Even when I go to church sometimes, to be honest, if I see a pastor say Genesis, what? Genesis and 1 quotes blah 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 blah. Man, believe me, I go in and check that. Yeah, I that is something I just do up to today. I just go and check and see. So I guess it started way back then with the maths. But yes, so here we know that if these two sides are the same, I want us to observe that these two angles will be the same. And as I was playing with the idea earlier, that is why we need to understand the sum of interior angles. So for example, if we know this triangle is an isosceles, I could easily tell you that, let's say maybe this side is 100. I could tell you, for example, this side is 100. And then I could ask you, yes, find x. And you might tell yourself, no, when we do in algebra, we cannot be finding two unknowns. But in this case, you need to understand, oh, this is an isosceles. There's a concept here beyond just the unknown. There's a concept here. If two sides are equal, then two angles are equal. If the sum of the triangle is supposed to be 180, and this side alone is 100, that means I have 80 degrees to shade. And since these two sides are equal, that means these two angles are also equal. So that means x is supposed to be 40 degrees here and 40 degrees over here. Just like that. And yes, that mightn't make sense to us now maybe, but hopefully as we do more examples in time to come, although to be honest, I didn't plan much videos practicing angles. I was more concerned with area and perimeter. But maybe sometime next week I could throw in one like this, just finding unknown angles, applying the concept of the sum of the angles in a triangle. So that's one way to look at it. And another way you could look at it, so of course, when you're given the dimensions, you don't have a problem. But what I notice with some students, they don't understand the labeling. So let me teach you the labelings. In any triangle, so sometimes I'm certain you would have noticed triangle with dashes like this. So if you see two dashes here, and you also see two dashes here, then this tells you that this line here and this line here, or let me speak the right language here, this line segment here, let's call it A for now, and let's call this one B. So line segment A and line segment B are equal. Why so? Because they have two equal dashes. And AN must be 2. If I want, I could put 3, I could put 3. As long as they have the same amount of count, they are equal. As a matter of fact, if I want to put 1, I could put 1. All this is telling you that this line is equal in length with this line. And of course, on a separate line, you will see another connotation. So 1 dash here, 1 dash here, that means that A is equal to B. But you see on C, I have 2 dashes, so that means that C has a different length. So this is one way in which you could identify it when no angle or no dimension is given. And the same thing applies for the angle. For the angle now, if I have 1 dash here and 1 dash here, all I'm saying here is that this angle, so let's call this angle A, and I know I'm using these notations wrong because usually the angle is the common letter. But don't mind. As a matter of fact, sorry. This is supposed to be angle B. So we don't need to know why for now. And this angle here will be angle A. Let's just leave that for now, so it don't matter. So because of one curve here and one curve here, 1, 1, that tells us that these two angles are the same. And likewise, like the dashes on the line, it could be more than 1 if I want. So if I put 2 here, then I have to put 2 here. Granted that these two are the same. And of course, then I will leave 1 here. And that's telling you that, okay, these two angles, A and B, are the same, but angle C is different to angle A and B. I hope that is clear. Let's move on. So here we're going on to know an equilateral triangle. And for the equilateral triangle, all we need to know now is that all 3 sides and all 3 angles are equal. And here I will not put in any dimensions because I want to go a little faster. I will simply put in the connotations. So for example, in an equilateral triangle, I could have 1, 1, 1. And then I have 1, 1, 1. So when I do this, all I'm saying here now is that all sides and all angles are equal. Or, of course, I could put 1, 2 if I want, 1, 2 if I want, 1, 2. You see, it's the same amount in 3 sides. So that is telling me that all 3 sides are equal. And let me see, I could put 1, 2, 3 if I want. Let's work with 3. Then I put 1, 2, 3. So that means the other one must have 1, 2, 3. And here I have 1, 2, 3. So that's all you have to look at. So what I'm looking at here now, okay, all angles are equal. All angles are equal. So all sides, sorry, and all angles. And of course, when you have the dimension, it makes it even easier. And one thing I should say here, I didn't want to put in any dimension, but one thing you should know, in any equilateral triangle, the internal angles for each angle will always be 60 degrees. And I think that goes without saying, right? Because it's a triangle, you know it will have 3 sides. So 60, 60, 60 will give you 180. It can be more, it can be less. The minute it changes, then definitely you no longer have an equilateral. Because an equilateral will be equal sides, equal angles. Yeah. And the last type of triangle now is the scaling. And I like to see the scaling as the opposite of the equilateral. So the scaling now has all sides and angles unequal. So they're not equal. So each side in a scaling triangle has a different length. And how do we represent that? So here we have 1 dash, here we have 2 dash, or 2 dashes, if that's a word, and then we have 1, 2, 3. You see? So this side is not the same as this side, and this side is not the same as this side. And likewise with the angles. So here I will have 1 curve, here I will have 2 curves, and over here now I will have 1, 2, 3 curves. So that tells us this is an scaling triangle. No sides is the same, no angles are the same. So that's a scaling for you. And let me just show in a dimension for in this one here for you. So if I use in dimension now, for example, I would have 9 centimeters. Let's say over here is 6 centimeters. And over here is obviously something different. So let's call this 11 centimeters. And that tells us straight away, okay, this is a scaling because none of the angles, none of the sides are the same. And same thing applies for the angles. So here might be what? Let's say here is, just making up generic values. Let's call here 7 centimeters. Let's say here is about, now let me go here. Let's say here is about 50, I say centimeters, degrees. So here is 70 degrees. Here is 50 degrees. And I know that all the sum of the triangle must be 180. So I have to be careful with the value that I put here. So let me work it out. So 70 and 50, that should give me 120. So that means that here is supposed to be 60 degrees. Yes. 60 degrees. Degree sign looking like a 0. It's a little thing, right? Let me change this one too. It looks almost like a 0. The degree sign is supposed to be like a little thing, right? So let's work with that. Yes, so this is an example of a scaling. If we go to have dimensions, we have 9, 11, 6, and then we have 70, 50, 60. And I try to keep, not try, I have to make sure that I keep true to the rules of a triangle in which the sum of all interior angles must add up to 180 degrees. So even if I'm making up these values here generically, I'm still making sure that that is demonstrated, right? So if you go to add 70, 50, and 60, you should get 180. And if you don't, it's because I make a mistake, not because there are exceptions there. But I didn't make a mistake. I think I had this correct. Good. Right. And then that gives us the bonus types. And other types of triangles include an acute angle triangle, an obtuse angle triangle, and a right angle triangle. I think the right angle triangle is very common. So this is what a right angle triangle looks like. And I so badly off, I always like to draw it in this orientation, but it could be in any orientation. So I could do it like this too. And this is the right angle. So what defines this type of triangle is basically the angle. Okay, we know they are triangle because you have triangle attached to the name. So that means it must have 3 sides. But then the angle is what is important. So in an acute angle triangle, we must have at least one acute angle. And what is an acute angle again? An angle that is less than 90 degrees. In an obtuse angle triangle, we must have one obtuse angle. What is an obtuse angle? An angle that is greater than 90 but less than 180. And in a right angle triangle, obviously the name speaks for itself, we must have a right angle. And that's basically all you need to bear in mind. So a right angle is 90 degrees, and here I showed you an example. Let me show you an example of an acute if we just need illustration. So an acute angle triangle might be something like this. This could pass for acute because this here is less than 90 degrees. So this angle here will be your acute angle. But as I was telling you earlier, this type of triangle could coincide with the main types also. Because a triangle could actually be acute and let's say scaling, for example. And I think you could analyze that on your own. And an obtuse angle triangle, most of them might look something like this. Good? And this will be your obtuse angle here. Right? So this angle will be obtuse because it is more than 90 but less than 180. And again, as I said, this could be a isosceles maybe, this could be a equilateral. No, never an equilateral. Take that back. So it could be a isosceles, it could happen to be a scaling triangle. Never isosceles, because we know for isosceles, it will always have 60, 60, 60. So never an obtuse angle in an isosceles triangle. That's impossible. Good? Yes, people. So that will bring us to the end of today's video. And again, as always, like, share, subscribe if you haven't done so as yet. Share it with a friend. Comment if you have any question. Turn on that notification, so that you will know when the next one comes out and you can be the first one to like it and look at it and we can learn some mathematics. In the next video, I will see you there where we're going to go deeper into triangles.